Hello, Ram55 here, and tonight I'm bringing you my next episode of the Kerbal Space Program NASA missions. Next in our series is the launch of Pioneer 5, which is a space probe to Eve. Now, you probably realize that Eve is the equivalent of Venus in the Earth solar system. It's the second planet away from the Sun. And here's a picture of the actual Pioneer 5 space probe. Now, that ball in the center is about the size of a beach ball. It's about 2 feet across and about maybe 5 or 6 feet from tip to tip, and it was launched on top of this rocket. It's the Thor Able rocket. It was launched on March 11th, 1960. And it was considered one of the most successful of the Pioneer space probes, as it studied the interplanetary space between the orbits of Earth and Venus. Now here's my version of that probe. And you can see there's a little motor on the bottom of that with a fuel tank, and that's just to give it some maneuvering once we get it out close to our target for some fine approach stuff as we get close to Eve. Now this is my third stage. This is the one that actually establishes our probe in orbit around Kerbin, but also gives us the thrust to escape Kerbin's gravity and start our travels out toward Eve. Now the second stage is simply a stage that gets us up to our periaps. It takes over from the first stage, which basically got us off the pad, gets us up to about the point where we start our gravity turn, and the second stage kicks in, gets us up to our periaps. Third stage establishes the orbit and then sends us on our way toward Eve. And then that last little bit of fuel and the small rocket is for fine-tuning as we get close to Eve to make our approach that much better. So here's our rocket out on the pad. Right now I'm opening up Kerbal Alarm Clock, and that second button to the far right there will set up a alarm for a rendezvous with Eve. And basically what it does, if you check that box, it says, okay, the next launch window for an approach from the launch pad to Eve is in so many days, and that's basically looking for a angle between Kerbin, the Sun, and our destination Eve of about -54 degrees. In other words, Eve should be about 54 degrees behind us in its orbit around the Sun. So once we set that up, it establishes Eve as the target, and also gives us an alarm so that as we approach that window, it slows down, and whatever we're doing draws our attention to the fact that, hey, you might want to think about getting your rocket ready to go. So we got that set up right now. Now I'm looking at the MECJEB2 information for orbital information based on our target of Eve, and I'm looking at the phase angle, which, as I mentioned, should be about -54, and I can time accelerate until we get to that window, and then the alarm clock will slow down our time acceleration. So here's our solar system. That's Kerbin. And we're measuring the angle from Kerbin to the Sun out to Eve, which is that yellow arc right there. Right now we're not at 54 degrees, so we need to time accelerate until that Eve, being on the inside orbit, catches up to Kerbin, and we get to that 54 degree mark. So now here we are, Kerbin to the Sun to Eve, and we're right at about the 54 degree mark. So that means we are approaching our launch window. So here's Kerbin, and you can see that blue line is the orbit of Kerbin around the solar system, or around the Sun. And our rocket is currently on the launch pad at the Kerbal Space Center right there. Now that bottom arrow is the direction of travel of Kerbin as it orbits the Sun. What we want to do is let that launch pad rotate, in other words, wait as Kerbal rotates on its axis until it gets just before sunrise so that we can launch, which is going to be right about there. So we can launch from that spot, establish ourselves in orbit, and then be in the right position on the planet for lighting up our burners and heading off toward Eve. So basically we've accelerated time. We're in our window. The Kerbal engineers are huddled over their consoles. They got their headsets on. They're poring over the data, and they're excited. This is the launch of a new chapter in the Kerbal Space Program. So we turn on the SAS for stabilization, fire up the throttle, and launch, and we are on our way. Pioneer 5 space probe to Eve. Now, unfortunately, this is a night launch, so things don't show up quite as well as they would during the day, but hopefully you'll be able to see enough of the launch and figure out what's going on. Once again, I am going to throttle down to keep my velocity below 200 meters per second. And that's a fuel conservation mode so that we don't waste as much fuel getting our probe out into orbit. Now once we get to 10,000 meters, we'll throttle up and we'll start our gravity turn. In other words, lean the rocket over on its side to give us some lateral acceleration, giving us the velocity that we need to get out into orbit. So it's a long, thin rocket. And that first stage will get us up to just past the point where we start our gravity turn. And then it's going to run out of fuel. So we're throttling up, start leaning it over, getting some lateral velocity. And we have flame out. Fire up the second stage, and this second stage will get us up to our periaps, the highest point of our ballistic launch. And right now I'm looking at the numbers in the MechJet screen on the top left, and that top number, the apoaps, I want that to get to 100. I want to establish myself in a 100,000 meter orbit around Kerbal when I make my transition and kick off toward Eve. Now as we approach 100,000 meters, I want to start throttling back. I want this to be a fairly precise burn. And then at 100,000, kill my throttle, and there we are at 100,000. Now I want to set up a maneuver node. And you know the drill. You pull on the prograde vector to circularize your orbit. And right now we're drifting up toward that 100,000 meter mark. Now that second stage is going to run out of fuel before we're established in orbit, and we'll kick up the third stage to complete the orbital maneuver. Now, since we're not in orbit yet, the first and second stages are simply going to fall back to Kerbal. We're not going to be left around as space debris out here. So that's good. So there we have it. We've established ourselves in orbit. And now we need to figure out where are we going to burn our rocket motor to send us on our way to Eve. So basically what you want to do is burn about 154 degrees from the retrograde vector. So remember that Kerbal is orbiting the sun in a counterclockwise motion, which is that line there. We want to burn retrograde because we're going to drop down to a planet that's closer to the sun than us. So we want to slow down, which moves our orbit closer, which means that we want to burn at that 150 degree point where that third little check mark was. Now I'm just pulling on the vectors so that the new orbit for our probe just barely skims the orbit of Eve, which will happen on the opposite side of the sun. Now it's kind of strange when you think about it. You're burning retrograde from the orbital direction of Kerbal. So you think, okay, I'm going to be going in that direction, but in reality, you're still going the same direction as Kerbal. You're just going a little bit slower. And it took me a second to really figure that out, and it kind of surprised me which direction I was going as I was orbiting the sun. That was probably obvious to you guys, but to me, I was thinking, okay, I'm going to be going the opposite direction. But really, all you're doing is slowing your vector down. You're going the same direction as Kerbal, but slower, which drops you down into a lower orbit. So I've extended the solar panels on the probe. Now we're burning that third stage, and we are on our way to Eve. It's programmed to be a 38-second burn. Total of 998 meters per second change in delta V. And it gives us a velocity change from 2,238 meters per second to 3,219 meters per second, which is enough to escape the gravity of Kerbal. So let's get rid of that note that we just used. And you can see our orbit is now that brownish yellow one. And over on the right side of the screen, it just barely edges into the orbit of Eve, which is exactly what we want to do, because that's about where we're going to rendezvous. Now, so next, I want to set up my next maneuver node about halfway to where that rendezvous is going to occur, but I'm also going to do it at that yellow node. And now that yellow node is the ascending or descending node. Because my plane is not aligned perfectly with Eve's, I need to get them up in the same plane to increase our chances for an encounter. And this is actually a descending node, so we want to burn up basically to bring our orbit up to the level of Eve. So that we've done that, we'll do a little bit more fine-tuning, trying to get ourselves an encounter with the planet as we get there. And we'll probably require a couple more burns. Now, scientists and the engineers back at the Kerbal Space Center are huddled over their consoles, and they're looking at the trajectories and speeds and altitudes and all that kind of good stuff. They're conferring with each other to say, yep, I think we got a successful launch. So here we are, time accelerating as we leave Kerbal. This probe will never see that planet again. Adios, Kerbal. Now, the real Pioneer 5 was initially intended to make a flyby by the planet Venus, but in reality, they changed the plan, so it was just launched out to test the inner space between Earth and Venus. And in reality, it was only powered up for about 106 days or so. So it ran out of energy long before it got to Venus. As we drift further away, you see the moon pass into view. And there goes Minmus shooting by. We are on our way into deep space. Cold, frigid, hot, dusty, and we are sending all kinds of valuable information back to the Kerbal scientists about the nature of space. Here we are in a bird's eye view of the orbit, and you can see that we are getting closer and closer to Eve, which is that yellow dot. It's on an inside track, so it's traveling faster than us and catching up to us. And we're approaching that maneuver node that I set up. And as we approach that node, we're set up for our burn. Pretty quick burn. Again, using that third stage. We still have plenty of fuel left to get us hopefully an encounter with Eve after this burn. And I want to be precise, so I throttle down toward the end. Come back out, look at the orbital information, and then cancel that node. You can see we're slightly ahead of Eve there in our orbit, but because it's an inside track, it's going faster than us, and will catch up to us as we come around to the far side, way over here. Now we still don't have ourselves set up with an encounter yet, so that'll take some more fine tuning. So I'm going to establish myself another maneuver node. After tweaking with that for quite a while, I finally got the encounter there, as you can see. And I cut a lot of that part of the video out of tweaking on the nodes, trying to get that encounter as close as possible. And you know, these are my first ever flights to other planets. I've never done this before. I mean, I've watched other people do it on their videos, so I understand the concepts, but I've never actually done it myself. So, you know, I was pulling on the prograde vector, the retrograde vector, the normal, anti-normal, and all that stuff, trying to get that maneuver node. And I'm still working this stuff out, but we do have an encounter with Eve here, which was ultimately the goal. And it was ultimately the goal of the Pioneer spacecraft as well. Now, as you recall from maybe my first video, the Pioneer spacecraft were launched between 1958 and 1978. And they were probes conducting various missions, including the first lunar probes, investigation of conditions in interplanetary space, and there is our first glimpse of Eve. If you got a really high-def monitor, you can probably see it, but we're getting close. I'm getting excited. So it was investigating the conditions of interplanetary space, exploration of the planet Venus, which is what this probe is doing, flybys of Jupiter, and later missions in Saturn. And it basically taught us how spacecraft operate in deep space, what the conditions were like out there, picking up information on radiation and solar wind and all kinds of valuable information that would help us in our knowledge of space exploration. So here's my probe, and you can see that we are getting closer and closer to Eve, which is now visible real close to the probe itself there. Scientists are back on Kerbin, using their slide rules and toes and fingers to calculate what kind of a burn they're going to need to get us a nice close encounter so that we can get good information as we fly by the planet. So a real slight adjustment on our burn there to get us a nice close approach. Down to about, I think it was 1,000, I think. 15,000, that's what it was, 15,800 kilometers. So we had a close approach with Eve programmed, and now we no longer need that stage. We are simply the probe with that little motor on the bottom, and I apologize for my spasticity here on moving the camera around so much. What I was trying to do was trying to figure out an orientation for my probe to be pointing toward the sun. I was trying to figure out an angle to best make that happen, so I apologize for the jerkiness of the video there. I want those solar panels to be pointing right at the sun. So hopefully I'm not giving you guys vertigo with all that camera shifting angles there. So there's Pioneer 5. We're basically almost on the other side of the sun from where we launched. We're going to set up another maneuver node just for timing so that we know when we're getting close to that encounter. You can see Eve just to the left of the probe itself there, getting closer and closer. There it is to the right of the probe. Time accelerating as it's catching up to us. That beautiful and mysterious purple planet. Amazing when you think about it, the vastness of space. We're on the other side of the solar system pretty much from where we started, and we are meeting our objective here. And we just had a sphere of influence change, 170 days, 46 minutes into our mission from the time of our launch, and we are now feeling the effects of Eve's gravity on our probe. For the next 9 days, we're going to continue to fly by this planet, gathering information on magnetic fields, particle information out in deep space, the effects of solar wind and radiation. And we get to appreciate the grandeur of a beautiful planet, an alien world as it slips down below us. One day we hope to visit that planet up close and personal. For the time being, probes are the way to go. At this point in our Kerbal Space Program, we haven't even launched a Kerbin into space yet. We've done nothing but launch satellites and probes. We've got 3 satellites orbiting Kerbin. We've got Vanguard 1 and 3, and we've got, Explorer 1 and 3 and Vanguard 1. And we have Pioneer 4 that did a flyby the moon, and this is Pioneer 5. So this is only our 5th successful space launch in our Kerbal Space Program. So there's that beautiful planet. And you can see the effects as we are in its gravity field, as it's kicking us out into a slightly different orbit than what we had originally had. And you can actually see the orbit of Gilly, the moon, which is a captured asteroid that is orbiting Eve as well. I took a quick look around, but the Gilly is so small it's really difficult to see, and I never did see it. I did try to see it. So I'm just going to try to accelerate time here and watch as Eve disappears off into the distance. All kinds of valuable data being collected by this probe and sent back to the planet. Kerbal for the scientists to pore over, and they are probably giddy with excitement. Now the real Pioneer 5 continued to send data back to Earth until April 30th, 1960, when it finally went out of commission. And here I am getting rid of and jettisoning that last stage, which was never used on this mission. And after I did that, I thought I should have kept it just in case I need to have another encounter. I can maneuver my probe. But as it is right now, we are literally a probe in space. We have no way to control this thing. We can control attitude. We have one of those command and control nodules on this probe. So we can rotate it, but we have no way to change our vector. So here's our Kerbal system. We have Pioneer 4 there on the left on that real light orbit that went on a flyby the moon. Successful launch and successful data was recovered from that mission. Now we're going to zoom in on Kerbal, and we'll be able to see the 3 satellites that we have orbiting our planet. As we move in, we see the orbits of Minmus and Moon. And here we have Explorer 1, Explorer 3, and Vanguard 1, all in orbit around Kerbal. And in the distance, way off in the distance, you can see Pioneer 5 kind of superimposed on Eve. So that's it. I hope you enjoyed this. Give this a thumbs up if you like this video. Subscribe. And as always, please leave comments and help me make some better videos. My next mission will be launching Echo. So keep the pointy end forward. Thanks for watching. We'll see you next time.